Hello everybody, this is Todd Frazee and we are now doing the TCOSE-14 CAM tutorial. This is the waterjet, the TCOSE-14 part. And you should have already programmed one part using the waterjet. So this tutorial will be more abbreviated. You want to go back in sequence and do the -3 before the -14. So we're going to open our data panel. And we're going to pull our TCOSE-14 part, or we're going to double click on our TCOSE-14 part to open it. And it should be defaulting to your design workspace. And I'm going to close my data panel so I have more room. And again, before we go into the manufacturer space, we need to create a flat pattern of this part. So we're going to go to the sheet metal tab. And we're going to create a flat pattern, and we're going to pick our largest flat plane as our stationary face, and we'll select OK. Should create a flat pattern that looks like so. You're going to exit your flat pattern mode. It will reappear over here, which you can toggle back and forth by selecting the round radio button to activate the flat pattern. And we're going to save. Make sure you save before you go between modes. Right now we're ready to go to the manufacturer mode workspace. So we're going to go to Design, Manufacture. And we're going to go to the Fabrication tab, which is where cutting is. The next step is you're going to expand the models, and you'll see the flat pattern under the model, and we're going to select the radio button next to activate flat pattern, and it'll flatten out the model. I'm going to readjust my screen so I can see the whole thing. And now we're going to highlight setups. We need to create the setup within our toolpath is going to go. So we're going to do one operation to cut this entire part. We're going to setup, create new setup. It's going to throw a default stock boundary around it. We're going to select on the stock tab. And then on the side offset, so let's do the same thing we did in the last one. We're going to put a 1/2 inch of extra material around the outside to clamp or whatnot. And our stock top offset is going to be 0 because we're going to be cutting a sheet that's already the thickness. All the other boxes on this worksheet here can stay at default. We can go back to setup. Our box point by default is the model box point. I think we'll just leave it there for a waterjet part. We just got to cut our material, make sure that we set our origin centered on the machine. And we're going to go to the post process, and we're going to use the same naming convention we've been using for our program so far. This is the part 14, and we're going to put 01 for the first program. And our program comment is going to be waterjet. Actually, waterjet is, I believe, one word. Operation. And that'll come up in our comments. And we're going to set our work coordinate system as 1. Okay, we're done with the setup tab. We're going to select OK. Now once we have the setup tab done, we're going to move on to doing our cutting. Now in this component, we want to cut our 4 holes before we cut the perimeter. It's just good practice. Make sure that the part doesn't shift. Even though we'll probably have tabs here, we can still have the material tweak and move when it cuts the outside perimeter and stress is relieved. Alright, so we're going to go to cutting, and we're going to select a tool we should have made in the prior tutorial. You're going to go to your TCOSE library, and we're going to pick the fine tip waterjet tip. We're going to hit OK. it should automatically plug in the default feeds and speeds. So we're going to leave those alone. We're going to go to the next tab, geometry. What are we cutting with this operation? Well, we're going to cut these holes. So we'll select our holes. Alright. Now we're going to leave all these other boxes at default. We'll go to heights. We're going to leave all those at default. We're going to go to passes. We're going to leave all these at default, except we're going to select smoothing. On a round feature, we want to make sure the smoothing is on. We'll go to linking, and we're going to need to make some changes here. We're going to set our lead-in sweep angle as 90 degrees, and then that way it'll plunge, it'll pierce, and it'll come into our hole at a 90-degree angle. We're going to have a lead-in distance, and we're going to make that smaller because we're doing a really small hole. So we're going to make that we're going to make it 0.060, which is about half the diameter of the hole. And we're going to have lead in and lead outs. And we're going to leave the pierce clearance alone. That's based off the diameter of the tool. And we don't need to select entry locations. We're going to select OK. And we should have toolpath that cuts each one of our holes. We'll want to double check that our lead in and our lead outs are inside the hole, which it looks like it is. Okay, now we're going to cut the outside perimeter. And we're going to go to 2D profile. Everything on the first tab is at default. Geometry. We're going to select the outside perimeter of our part. Make sure the arrow looks like it's on the outside. And we're going to select this tabs feature. And we're going to make our tab width smaller than that. Our material is 3 millimeters thick, so we want our tabs to be probably about half of that. And so that would be about 0.06. And we're going to put a tab every inch because this is a very small part. And it previews where our tabs are going to go. And that's actually pretty good because those are surfaces that will be easy to file. Hit OK. And we generate our toolpath. Now let's go to simulate. Pick your setup so it simulates the entire setup. And we'll hit go. And make sure that your stock is shown. And hit play. We do our 4 holes. We come in and cut around our material. And our tabs. And when we're done, we should have a pattern that looks something like so. And you should be able to see through it. And we cut our bend reliefs. And that should be everything for this part as far as programming. Now we're going to hit close on the simulation. We'll go back to home view. And then we want to select the setup. So it displays the stock. I'm going to zoom out a little bit so you can see the entire stock. And it's centered because that's the view that's going to occur in your setup sheet. Make sure setup 1 is highlighted. You're going to go to the document icon here. It's a setup sheet. You're going to select your folder it's going to go in. So in my case, I put it on my desktop. Okay, select the folder. And it should pop up with a HTML version of a setup sheet showing the part, the origin, and your basic information on your 2 operations. Alright, so you can either save this as a PDF or a HTML. So I'm going to save as in this case. I'm going to save it as HTML. And I'm going to save it in my advanced manufacturing and hit save. The alternative is to print it to PDF. Either one works. I prefer PDF if you can do it. Close the setup sheet. And then the next thing is to post-process. So you're going to post-process, make sure you have the OMAX waterjet selected. Make sure the Open NC file editor in file editor is checked. You should have your program number that you set up in the beginning and waterjet operation as the comment. Hit post. It's going to go to a folder that you designate. So make sure you know where this is. And I'm going to save it in that same folder I made my setup sheet so that I'll have the 1401 OMAX file and the setup sheet for the 1401 HTML file in the same directory. Save. And if you had that checkbox set up, you should get a code file like this. And to submit your assignment and get credit, you're going to need to submit the 2 files you just generated. You're going to need to submit the program 1401 OMAX and the setup sheet for the 1401 program in either PDF or HTML format. And those are submitted in Canvas. And you're free to move back and forth between the different workspaces. So if you go back to design, there's your folded part again. And if you switch back to manufacturer workspace, there it is in the machine version. And you do not have to save off a separate Fusion file. It's all in one file with different workspaces. That's it for this tutorial. Thanks again, and I'll catch you on the next tutorial.